Hey, it's a Steel Lodge. Today we're going to be looking at a script that I wrote for The Witcher 3 on Steam Deck that lets you set custom resolutions, 16 by 10, 16 by 9 aspect ratio, or even custom resolution with whatever aspect ratio you want. Python's installed on the Steam Deck by default. If you open up the console and desktop mode and type in Python, you'll see what version of Python's installed. Python's a really easy scripting language to use, and it makes something like this pretty straightforward and easy to do. I'll be going over the contents of the script and how to use it in this video. In addition to that, this script works pretty nicely with the update for the Steam Deck that lets you set custom refresh rates from 40 to 60 Hz. That way, say you want to play at 50 Hz, dial in a locked frame rate, you can mess with the resolution a bit and use FSR to make sure you always hit that frame rate. Let's jump into it. First off, we're going to go into the URL where you can download my script. I made a tiny URL version of this so it's easier for you to type into the Steam Deck if you're using the Steam keyboard instead of an external keyboard. It's just tinyurl.com/TW3CR. This will take you to my GitHub page. From here, you can look at the code if you want to. On the right-hand side, you can look at the releases and jump in there to actually download the files for a released version. In this case, version 1 is the only version I've released so far. For Linux, you're going to want to grab the tar.gz file. This is a zipped file that opens on Linux. You can just open it with the default file explorer for the Steam Deck. And here we'll have the files. Now extract the whole folder to whatever location you want. In this case, I'm going to extract it to my downloads. Now to run this script, you can right click and open up the terminal here. On the Steam Deck, that's just by pressing in on the left trackpad. Open up your Steam keyboard and do /run.sh. This will call the Python script and it just saves you some time typing in more characters. Now if you do this the first time, it'll probably fail, and that's because you don't have permissions to run a shell script like this. What you need to do is just type in chmod and then do +x on the file name. This will give that file permissions to execute on your machine. So with the permissions modified, you can now execute the shell script, which will call the Python script. Now we are prompted by my program to enter in an aspect ratio 16 by 10, 16 by 9, or custom. Before that, I'm actually going to go ahead and go to the files that this is going to modify to show you where exactly they're located and what's going to change. It's pretty straightforward. It's just one settings file. So this is a settings file for The Witcher 3. Right now I actually set a resolution of 1120 by 630, and that was using my application to test that out earlier. So just keep that in mind, and I'm going to go ahead and finish running my program here, and we will check that again to see what the resolution is. It might be a good idea to make your own copy of the settings file just in case anything weird happens. You can go back and reference the original version. With all that done now, we're going to put in a 16 by 10 resolution here. Once we enter that in, it will prompt us again for a horizontal resolution, and from that horizontal resolution, it will calculate a vertical resolution that is equivalent for a 16 by 10 aspect ratio. In this case, I'm going to put in 960. The program is going to go ahead and calculate us a vertical resolution, which is 600, and that fits the aspect ratio. And now if we go to the settings file here, you can see that our resolution that we just entered in has now been inserted into the Witcher 3 settings file. Now, one resolution I was curious about testing out is 1000p And I believe that's 1000 by 650 or 625 for the 16 by 10 aspect ratio. So here I'm just using my script and essentially entering in that resolution. And then I'll put up some gameplay after this to compare the quality of it using FSR with 1000p and the frame rate difference that you're going to get. I'm going to go ahead and use medium settings to compare against 1280 by 800. The graphics settings here are identical besides the resolution. Post-processing effects generally enabled, and all settings set to medium generally. When we actually look at the comparison here in a cinematic where we get some good close-ups of characters and you can see the texture work on objects and people, it's really close, honestly. Using a slightly lower resolution like this, and then using FSR to help scale it back up with sharpening, works pretty well, and you do get some performance benefits, which we will go over later. Just try to look here closely and examine the differences between the texture work and the quality overall between the two.
What? Time to wake up, Master. These lessons so boring they put you to sleep too?
Damn it. After taking notes on ghouls and owl ghouls, wanted to rest my eyes a bit.
Making her slog through that brick? No wonder she took off.
John of Bruges lacks flair, true, but he's reliable. Not like the hogwash they print nowadays. She's tackling the pendulums, right? How many times do I have to tell her? Don't train alone. It only...
Now we have a more direct performance comparison. Here I just ran on the horse through the same area at the same time of day. If you look at the frame rate graphs between the two, you'll notice that the FSR one is about 10 FPS higher, and the visual trade-off is really not bad at all. You could lock a FPS of 50 on the 1000p version and stay there almost 100% of the time, I'd say, and you get a little bit more battery. The visual difference would not be that significant at all, and the game would feel great still. Hey, so now that I've kind of gone over how the script works and the kind of performance you can see, let's go over how the script actually works and everything. So here's the GitHub page that I have pulled up. Version 1.0 is the version that you guys can download, and that's just the same as my main branch right now. But this is all on GitHub, so the code is completely open. It's totally transparent. You can click on any file, and it will open and just show you what my code is like. So this is actually the Python script that does all the lifting for the program. The shell script right here is just calling Python on the file, and that just makes it a little bit easier to run if you want to run this a bunch of times. Just punching in a few less characters on the Steam Deck, if you do it over and over again, will save you time. So that's kind of the purpose of that. I was trying to make this so you could just click on it and run it, but that really honestly didn't work the best. Here's just the README. This is literally what you see on the GitHub page when you open it up, or if you were to open up the text file of it. This is just the MIT license, and then right here we have some test files. This is just pulled right from The Witcher 3, and I can show you how you can use these locally to test stuff. This is the one that I was actually testing on initially for my program, just to make sure that a mini version like this could be modified and updated before I moved it onto the Steam Deck. And here's actually a backup version of it if you want to do some comparisons, which I can show you in a bit. There is one thing I want to talk to you guys about, and that is that there might be one error with this program, and I want people to test it and let me know if they do run into this problem, because I can't really test it. And that is that there's a settings location string. It's a constant that's defined at the top of the actual program here. And this is essentially telling the program where the file you want to operate on is located. And as you can see, for the Steam Deck, that's never going to change regardless of if you have it on the SSD or the micro SD card. It's always going to be in this location. The one thing that might be different is this part right here. So for me, I just have Witcher 3 Wild Hunt, and then I got the DLC later on, and this is the app ID that Steam gives the game. But there's also the Game of the Year edition. And I don't know if this actually will affect the string here or not. So if you have the Game of the Year edition, please try to run this script and tell me if it crashes. It'll tell you in the code here if it crashes, and if it does, let me know. Because the app ID for the Game of the Year version is different. And if that is the case, it's super easy for me to go in and update this code so you can use either version. I'll just put a little request at the front, and whatever version you're using, I'll change the string accordingly. So going back over into the actual Python file here, I will zoom in slightly to let you see what's going on. Like I said, this is the settings location. I'll show you a little bit later on how you can run this locally on some different files. This is just an enum that will let me do some comparisons easier and returning values to compare with that will be easier for me to read and just make more sense. So now we actually get to the main part of the program. So this essentially is what runs right away, this function, when you call it. Right here, it prints out this prompt to the terminal, which is what you guys will see. Enter in a custom resolution for the Steam Deck. And then it's going to go ahead and try to open that file that's listed up here. So if this file doesn't exist, let's say, for instance, I do something like that, type in some random letters here, and I go ahead and I run a terminal from this location, and I run my script. Oops. Okay. You will see that it's going to try to run it, and then it will warn you the user.settings file for The Witcher 3 relevant does not exist in the expected location. Make sure the game has been installed and run. If both are true, contact me, and then it'll exit the program. And that's because this location that I just put in doesn't exist. And likewise, since I'm on my desktop right now, this actually won't run from here, but I will show you, like I said, later on how to run it locally. So if it's successful in actually opening it, it's going to read all of the lines to a buffer, which is basically just an internal data structure, an array where I can access those files locally and have a copy of them. We go down here and I ask the user for the aspect ratio. If we scroll down, this is what this function does. Essentially, it's going to ask you what aspect ratio do you want, 16 by 10, 16 by 9, or a custom aspect ratio. I will get rid of the case on your input, so it doesn't matter if you enter custom with whatever shift letters, like capital letters you want. It will work regardless if it says custom in all caps or no caps. If you don't input a valid aspect ratio, I'm going to prompt you again for a valid aspect ratio. And then whatever aspect ratio you do select that is valid, it will return an enum that corresponds to that aspect ratio. And that's kind of what I talked about here earlier. What would be something that would make more sense for the program to look at instead of just returning some random thing here. And it'll prompt you again for a valid aspect ratio if you input an incorrect one. So here I get the aspect ratio. That will be one of these values. And I go ahead and I open the file for writing. When you open the file for writing like this, it's going to nuke the file. And that's why I saved all the contents of the file to this buffer. So now I'm going to go line by line. For instance, I'll start from this line and then go to this line and go to this line, then this line, and process each one of them. The first thing it's going to do is it's going to split the lines, each line looking for this equal sign. So for instance, right here, spawned equals 100. This would actually become something that looks like this. And then comma 100. So this is what this would actually look like for me now. If I want to access it, it'll turn it into an array. And this is a lot easier to work with because now, let's say I named my array like just list. If I want to access this part of the list, I can just type list 0 and it'll access the first index here, spawn limit, and return that string to me, which is spawn limit. If I want to access the second part of this, I can do 1, and it'll access the second entry, which is 100, and return that value to me. So it's easier for me to process this way. And we're essentially looking for this string resolution, which if we scroll down here, resolution. So this becomes something like this. That's what that string's going to end up looking like. And like I said, I'm looking for this resolution part, so it will identify that is there and only operate on that part of it. Let's just get rid of all that, just make sure nothing is different. Okay. So if it has that at the beginning, it will actually do the work on it. If it doesn't do that, all we're going to do is write out the line literally exactly the same as we got it handed to us. So this is why the program only touches one line of code, is because all the other entries in this user settings file are going to get spit out and be exactly the same. So if it is resolution, I'm going to just assign it 1280 by 720 by default for width and height. If you have a custom aspect ratio, I'm going to prompt you for a horizontal resolution, and then I'm going to prompt you for a vertical resolution. This function down here is just going to try to get input from the user again, and then I'm going to make sure that the input from the user is an integer. For instance, 960, no decimals, and not a string like cat as an input. If it's not an integer, it's going to prompt the user for input again, and it won't get through unless you actually give it an integer. Once you do get an integer that's valid, you'll go in here and it'll set the resolution to be width and height, and then it'll actually go down here after all these checks, print out what the new resolution is, assign it to a new variable, which is just a string that is looking exactly like this one here, but with your values in it instead, and then it will write it to the file in the location where this string actually is located. And if you want to use one of the other ones, like the aspect ratio ones that do the calculations for you, it'll go down here instead and check, print in a horizontal resolution. It will prompt the user for a width. If you selected aspect ratio 16 by 9, it'll go down to this check and give you these ratios that it'll do some math with. And essentially just multiply the width by the ratio to get the height. And it'll use this int just to make sure that if you have any decimal places, it'll truncate those and cut them off and turn it into an integer, because there is no resolution that can be a decimal place. It's just has to be an integer. And it'll go down the same path. Once it has that height, it will print it out to the console and then write it out to the file. Sorry if you can hear my dog in the background. He wants to play very badly. Okay, so I'm going to run this locally and just show you some stuff. So I'll go ahead and split these up and zoom out a little more. So I'm going to go ahead and change this file out. And this is how you can test this locally too. I'm just going to cut all that out. And then I'm going to go ahead and, oops, don't want that notion to pop up. Good. Okay. So this is the location of my file. So now if I run this locally, again, so just if you type cmd in here, it'll open the command prompt wherever your folder is located. And I just do Python, and then you can actually just press tab on the keyboard to complete input. See if I put T and I press tab, it'll do test. If I press it again, it'll actually go to TW3, because that's the other thing that starts with T. I hit enter. It'll run, and it'll say that this file doesn't exist. And that's because there's actually this test right here. And now if I run the file, it should actually execute this time. So like this. All right, there you can see it's working. So this time I'll do a 16 by 9 aspect ratio, since I've been doing 16 by 10 in the test. You can see that it nuked the file once the thing was accepted, because it's saving it all to a buffer, then it's going to rewrite this whole file. Then I'll put in 960, and it'll tell you what the new resolution is, and it'll actually just go ahead and write it right out to the file here. If you look for the resolution right here, it's right there. And if I want to, I can actually show you exactly that this only operates on one file. So if I undo this, and then I go ahead and copy this and make a paste of it, and just call this one comp.settings, and then I run. So we have 720p again now, and if I go ahead and open the command prompt and run literally, I'll go custom this time and enter in a horizontal. I'll say 540 and then by 100, some ridiculously low resolution. You can see that that's valid too. I might set checks in the future of this program to make sure you can't do ridiculous things like this, where you can't go too high of a resolution or too low of a resolution. But for now, you can do whatever you want. Okay, so now if I do FC and I go ahead and input the location of my files, so that would be test, and then user.settings, and test, compare.settings, I believe is what I called it. Let's double check here. Comp.settings. No such. Let's see. Let me just open it in here to make sure that I'm not making any mistakes. So file compare and then comp.settings and user.settings. And here you can see it'll bring up the line that is actually different, and it just brings up the adjacent lines here also. So you can see in comp.settings, we have a resolution of 1280 by 720. On user.settings, we have a resolution of 540 by 100, and those are the only lines that changed, actually. That's it. Well, thanks if you made it all the way to the end of this video. I don't expect many people make it here, but I hope you liked it, and the code overview was insightful for you. I make a lot of videos just like this one for the Steam Deck, and I'm hoping to make some more automated scripts with Python on the Steam Deck in the future, just to make things easier for people like installing mods and moving files around. So, thanks for watching, please subscribe, and have a good one.